You ever look at the THC percentage on a cannabis label and just wonder why the reality doesn't quite seem to match the number? Yeah, you are not alone. Today, we're going to dive deep into the science of what's really happening between the plant and, that puff of smoke.
Right? You see this big number on the lab report and you think, okay, I know what to expect. But then it feels like a huge chunk of that potency just vanishes. It literally goes up in smoke before it ever gets to you. So what's the deal? Where is it all going? Let's get into it.
All right, so first up, we've got to tackle this whole lost THC question. We're really just going to unpack the difference between what that label says and what you actually experience.
And you know what? It all comes down to two specific molecules. You can almost think of them as the main characters in our story today. You've got THCA and you've got delta-9 THC. So let's start with THCA. I kind of like to call it the locked potential. And here's the thing you really need to get. Raw cannabis flower, it doesn't actually have much of the active THC you're probably thinking of. Nope, it's mostly filled with this other molecule, this precursor. So what is it exactly?
Well, THCA, that's short for tetrahydrocannabinolic acid, it's a non-active cannabinoid. The easiest way to think about it is like pre-THC, or locked THC. It's got all the parts, all the building blocks, but it's stuck in this locked state, so it can't give you those familiar effects. Well, not yet, anyway.
Okay, so how you unlock it? The magic word here is decarboxylation. It's a simple idea. You start with the raw plant, which is full of that locked THCA. Then you add heat. Heat is the key, and boom, you get active, unlocked delta-9 THC. Sounds easy enough, right? But, and this is a big but, the process is nowhere near perfect.
And that brings us to the very first place where potency just disappears. And this isn't a maybe, it's a hard limit. It's baked right into the chemistry of the whole thing. People call it the 88% conversion rule.
Or, if you want to get super precise, it's 87.7%. That number, that's the absolute max you can ever hope to get. I mean, even if you were in a perfect lab with a totally flawless reaction, getting 100% conversion is just chemically impossible. Can't happen.
So, why? Why does this happen? Well, during that heating process, that decarboxylation, the THCA molecule literally sheds a piece of itself. It loses this little thing called a carboxyl group. And because that group has weight, it has mass, the final delta-9 molecule is physically lighter than what it started as. It's a simple matter of physics.
And there's a great quote about this that sums it up perfectly. It says, you don't get 1 milligram of delta-9 out of 1 milligram of THCA. It just doesn't happen. The chemical math simply doesn't add up. So right out of the gate, you've already lost about 12% of the potential potency.
But listen, that chemical loss, that's just the first hurdle. Because on top of that unavoidable 12%, you then have to deal with, well, real-world inefficiency. This is where how you actually use it starts to cause even more waste.
So it's really important to separate these two things in your mind. First, you've got the theoretical loss. That's the chemistry part, the 12% that's always gone. But then you've got this real-world loss, which is totally variable and just gets piled right on top of the first loss.
So what causes this real-world loss? Honestly, it's stuff we can all probably relate to. You've got uneven heating, which means some of that THCA never even gets unlocked. Then there's overheating. Burning it too hot for too long, which can literally destroy the delta-9 you just worked so hard to create. And of course, the most obvious one, any smoke that just drifts away, yep, that's active delta-9 you're just not getting.
Okay, so with these two different ways you're losing potency, how can you possibly get a more efficient result? Well, it really all comes down to what you start with. A plant that's more mature, one that's already naturally higher in delta-9 from the get-go, that's going to give you a much more predictable outcome.
And the logic here is pretty simple when you think about it. If the flower already has a bunch of active delta-9 THC before you even light it up, then you're just not relying as much on that messy, inefficient conversion process. There's just less to lose in the first place.
Let's break it down real simple. If you have a high THCA plant, most of the good stuff is locked. That means it needs a ton of conversion, and the risk of waste is super high. But if you start with a high delta-9 plant, it's already mostly active, so it needs very little conversion, and the risk of waste, way, way lower.
All right, let's wrap this all up. We've gone through the chemistry, we've gone through the real-world stuff, but how would you explain all this to a friend in like 30 seconds?
Here's the simple version.
Raw cannabis is mostly that locked THCA. Heat unlocks it into the active delta-9 we all know. But you always lose at least 12% just to basic chemistry. Then you lose even more from things like burning it wrong or smoke escaping. So the bottom line is, a plant that starts with more delta-9 already active is just going to be more efficient because you're wasting less during that whole conversion step.
So that really leaves us with just one final thought. Now you know the real difference between the potential THC in a lab report and the active delta-9 you can actually get. So my question to you is, the next time you see one of those reports, are you going to look at those numbers a little bit differently now?